unmute myself. All right, everyone. I hope the remote crowd can see me as well and hear me. It's a pleasure for me today to have the first hybrid event. Just gonna go a bit distant so the audio doesn't overlap. Today we have Professor Dima Damen here. She's a professor of computer vision at the University of Bristol and is an EPSRC fellow. And her research focuses on the automatic understanding of object interactions, actions, and activities using wearable visual and depth sensors. She has contributed to novel research questions, including assessing action completion, skill expertise determination from video sequences, and discovering task-relevant objects, dual domain and dual time learning, and multimodal fusion using vision, audio, and language. She's also the project lead for Epic Kitchens, a dataset which you might have all heard of, which is the largest dataset in egocentric vision. And she also leads the Epic annual workshop, which has been presented at CVPR, ICCV, and ECCV. And she is also involved in the Ego 4D dataset, which she is going to talk about today. And yeah, this is the first hybrid event of this sort, and we hope we'll have some more in the future. And yeah, let's see how well this goes. And
echo, and that's going to be fun. I think I need to figure out how to mute.
Right.
Well, I can't hear my echo. I can hear yours, so maybe we're fine.
Okay. Yeah. So, can you unmute yourself?
I am unmuted.
All right, then.
Okay, then we're fine. We're fine.
Without further ado.
Okay. Hopefully, someone at the other end can confirm that they can hear us. So that's a good sound. And if I get too far, let me know. Yeah, I haven't tried something like this before. Right. So this is my first in-person talk, and I don't know how long. I feel that I've lost all the skill set. So let's see how it goes. And as usual, I have too many slides. So again, let's see how it goes. But stop me at any point in time if you have any questions. Right. I am here to tell you about video understanding, particularly from an egocentric perspective. So all the wealth of titles that Yuki had mentioned, all are related about this idea of how can we interact with objects in the world. Computer vision has seen a set of sources all the way from movies, moving into collections of footage that is from TV. There is now an increased set of videos we haven't yet analyzed in computer vision, but increasingly they will be coming. They are a lot less on the curated side. One of the topics that had probably transformed how we do computer vision is looking at how-to videos, these procedures. I have put them partway between ego and third person because they tend to have this better view on you doing actions. Vlogs, there is a data set of vlog, and these are these YouTubers who tell you every detail of their life. And egocentric and unscripted, and I was going through a set of this footage to tell you that this is completely unscripted. So we just watch someone going through the interesting and the boring aspects of their lives. Why do we like egocentric footage? Because it's allowing us to answer a good number of questions we haven't yet attempted answering in movies or in TV sports. Because it's not really, why is someone doing sports? They're jumping, they're winning the competition. But looking at footage of someone in the kitchen, why did they decide now to wash the dishes? Maybe because, the sink is too full. Maybe because they are waiting for something else to actually finish and there isn't anything else to do. Maybe they're obsessed with washing. Every bit they finish, they wash. And all this aspect is a new idea about how we can analyze. When exact moments at which we can understand perception, where this is not something we've done, but people have used egocentric footage to track and build a map of the world. The only thing that egocentric footage isn't really worried about is the who, right? Because this is the camera wearer. You're following them, you know who they are. So there isn't a like which person had done this, it is the camera wearer, but all other questions can be addressed using egocentric footage. And the first insight we had in this is this data set I've just shown you images in. And we started by collecting the data first. And I'll show you this quick cycle of what we've done with Epic Kitchens. We collected some data, then we narrated this data after recording. So that means we've given this a description of what's happening in the videos. From these, we went and annotated start and end time. So this is the standard dense representation of actions. And we first released the first version of the dataset, which we now refer to as Epic Kitchens 55. That's 55 hours of this type of footage. After that, we learned from the experience, and we went and did another set of collections. We improved the way we do our narrations. We improved the way we do our annotations. We actually increased the average number of actions from 13 per minute to 20 per minute. So these are really very, fine-grained actions. And then we released what you have now, if you want to use Epic Kitchens, which is Epic Kitchens 100. Okay, so am I telling you about yet another large-scale data set? From one end, yes, but this is a little bit different than what had been ongoing and still ongoing in machine learning in practice. So let's assume you start doing your PhD in a topic, say you want to address object recognition, and you think, okay, I need some data to train on because it's all about computer vision now is all about this machine learning expertise. So you go and say, okay, I need to collect a data set for the task of object recognition. Okay, let me then find objects. Maybe you'll follow the ImageNet style. So you have a representation of the world and a set of classes from that representation. You take those representations and you find the source of collecting the data. You get a bunch of examples of that class and you put them into your data set. And then you do the same until you have a data set for object recognition. And then you go through this cycle of training a model, and hopefully with time and with improvements in your approach, your error is decreasing, right? And you think, okay, I've solved the problem. I am now on 98% in object detection in my data set. Until someone builds a bigger, more complex data set, and you're like, okay, we haven't solved object recognition. So let's rethink again, how can we do it? And this is the case in most techniques. So data sets are created for certain problems. Kinetics for action recognition, ImageNet for object recognition. Except, that means that data sets are really, the methods overfit the data set, but more critically, the data set is useful for that task it was created for. And it's, of course, biased by the choice of researchers. Do we collect this class or do we not collect this class? Do I collect 10 examples or 300? And making it unnaturally biased, unnaturally balanced, that means, you try to collect 1,000 examples of every class. You might fail, but this is the attempt, right? Even kinetics is not fully balanced. The attempt is to make it balanced and you run out of options. And that's not the world. The world isn't really this, except really one exception that had inspired how we collected Epic Kitchens. And that's the Kitty dataset. So the Kitty dataset didn't start with, let me solve optical flow in cars. It was like, let me put sensors, let the cars go into the streets, and then from that, find the set of possible problems I can create for this dataset. And many people will say Kitty has transformed autonomous driving because of the way, of the approach it went into collecting data. So that's what we wanted to do. We wanted to collect data first, worry about the problems later. And that's what made Epic Kitchens. We took cameras, we gave them to people, and we said, collect data. The problem with that is that your data is unlabeled. It's huge, but it doesn't have any description of what it contains. And we, in that sense, that's what we had. We had this wealth of footage. Now you're seeing it in the normal speed. We have this wealth of footage of people. They started recording as soon as they stepped into the kitchen. They stopped the recording as soon as they stepped out. And, no labels. So that's the scary aspect of how do you deal with this type of data. And in that sense, we borrowed, I told you movies is where the whole thing started. And it started there because movies had narrations, had subtitles that people used to access movies. So we wanted to create subtitles for our footage. And that's a good way to start. Also, that's how 200 million uses all these subtitles that appear in YouTube. So we wanted to create subtitles. We call these narrations, inspired by the notion of these narrations in movies and in YouTube videos. And these are basically one moment in time and a free-form sentence that describes this short action, pick up tofu or fold the kitchen roll. And one of the discoveries we had is that people can only do this in their native language. Even if you spent 20 years in the Netherlands, you probably don't know the name of a particular item in the kitchen except in your native language because you're not going to use it otherwise. So we had to do that in people's native languages. And from that, that gave us an easy way to then go and do the standard in computer vision, which is, okay, there is something happening here. Where is the start and end time? And how can we map these free form into classes? And if you're using the action, if you're doing action recognition on Epic, that's what you use. You have start and end time and a verb class and an out clause. Okay, so, right. And eventually now we have what we typically had, which is a bunch of examples of exactly the same action, but they are not in isolation, and they are sometimes interleaved with other types of actions in between, and they are from this egocentric perspective. You actually see the kitchen being opened. Hazel has recognized her old kitchen. Right, and from that, we currently have 5 open challenges. However, as you've seen, if you looked at some papers out of Epic Kitchens, many people have used Epic even outside these defined challenges. But currently we have 5 open challenges: action recognition, detection, anticipation, domain adaptation, and multi-instance retrieval. And if you're interested, the deadline for these are the 1st of June. And last year we had the set of winners virtually. Hopefully this year we'll have again the set of winners in person. So the simplest is, as we said, the action recognition challenge. Look at the wealth of Epic, and now I'm kind of going down into this boring problem of action recognition. That means we've given you the start and end time that is extracted, and the only thing you need to do is what verb and what noun, right? So we're still doing basics, but the dataset offers a lot more. And again, people can submit to the challenges and see how well they're performing. You want to know more? I will leave that bit and go into what types of problems we're trying to solve with applications. Okay, I think I will definitely run completely out of time, so let's see what I need to jump. But one question I am still passionate about is, did we need this effort? Did we need to go from these narrations to these start and end times and class labels? And one of the first works we've done is, can we learn from these single timestamps? Because I know there is an action roughly here. I don't know where the start and end time in the old style, of kinetics or UCF, but I know an action is roughly here. And in fact, we started with these narration timestamps as an initialization. So we said roughly here, there is this action, and we did this work that then learns where exactly the action is. So it's a weakly supervised manner, but I know that people have done weakly supervised in video, but typically the video has like 6 actions. Here we had 500 actions. So the video level description is not really sufficient. You have to start a little bit better. And this is where the single timestamp started. So you basically say, okay, roughly it's here. And with time, you can train a model. And hopefully, if you're going in the right direction, you'll end up with locating roughly where the action is. And if you look at this paper, you'll realize that the methods actually localize a smaller bit than what we have defined as the start and end time of actions. So if you're opening the fridge, the method will end into this bit of opening, and this is enough for it to recognize the open. So our traditional start and end times are not the best suited ones if you train in a completely weakly supervised manner. I'm going to skip the examples, and you can look at this paper in details. This is an overview of the problems we attempted to do. I will only address a few of these, but if you're interested, you can look at some of these problems. We've addressed how well you're doing something, a bit of supervision, vision and language, and vision and audio. And I'll address one of these aspects. I'm not going to take you to a skill because you've stolen our skill expert. So if you have any questions, you know who to ask. I'll mention action completion because this is a topic I love. I don't have anyone working on it at the moment. I keep talking about it, hoping someone will pick it up. Hasn't happened yet. But this is the idea of understanding the moment at which you know the person had achieved the action, say picking up. Or you observe someone attempting an action and you know they haven't successfully completed it. So this is the exact moment at which you know the goal of the action has been sufficiently completed. When exactly did they pick up? And we've addressed this with Farnoosh, who was a PhD student in the group, in 2 ways: with supervision, so with this label given, and with weak supervision, with video level, complete and incomplete. And I'll show you some of the outcome examples. So you have, this is from HMDB as a data set. So you have the blowing candles and the moment at which the candles are blown, as well as the case where this poor kid keeps blowing those impossible candles all the way till the end of the video and fails miserably. So it's not really finding the actual frame, This is also knowing when it doesn't exist. So this is currently done on one action at a time, but you can see it for a variety of actions. When exactly did the person drink? Or the cases of, doing sports, has this person achieved their goal, or was this a failure? And of course, it's interesting that if you look at how the method is learning, it's actually not looking at the ball at all, it's looking at the reaction of the player. And that's enough to know whether it went in or didn't go in. But, that's what learning is about. A big thing that we've done with Epic Kitchens is collecting footage from multiple environments, multiple people's kitchens. And that's what you're hoping. You're hoping in the future, we don't have to collect data from every individual kitchen in the world. Otherwise, we'll never finish computer vision. And in this work on unsupervised domain adaptation, the idea is that you can train on a single kitchen. And when we did this work, the state of the art of action recognition was this two stream of RGB and flow. So you train this model from evidences from one kitchen, and then you try to recognize examples from a different environment, a different kitchen. And if you try to do that, we know that we don't generalize well. So you'll realize that even the feature space, they don't overlap. It's completely broken. And in this work, in unsupervised domain adaptation, the assumption is that you have access to the footage in the new domain, but without labels. So in this work, we used the trick of self-supervision, which is trying to know whether the RGB and flow are aligned or not. That doesn't need labels. And you do it both in the labeled domain, the source, and in the unlabeled domain, the target. And just by saying, is it, is coming from the same action or from different actions? And just through the self-supervision, you see that these target domains are clustered now into relevant actions. They're not overlapping, but they're now nicely clustered. And with a bit of adversarial, so this is a gradient reversal layer that says, now make sure that you can't distinguish source from target. Then you go and kind of say, I shouldn't be able to distinguish. You do it on both modalities, and you end up with a good overlap between the two domains, as well as a good overlap between the environments. So these are examples of someone cutting. We've learned from one environment, we want to recognize in the other one. And initially, in source only, these two videos have nothing in common. They're very far. With the self-supervision, you get the clustering. They actually also get closer to one another. And with the adversarial, you're achieving this alignment. This is actually in Johnny's thesis. So it's not in the paper, where we've actually done audio as well. And we've seen the ability to integrate audio and flow. So if you haven't seen this, you can also ask me to look at Johnny's thesis. There is a bit of work we've done on domain adaptation and retrieval, only on archive if interested. I'm going to skip the bit on few-shot TRX and say, if you're interested in few-shot domain adaptation, we not only have a very good model, but a good code base that Toby has nicely created that not only has our method, but all previous methods. So you already have the code for all previous methods, should you be interested. Okay. So we're doing okay. I can always speed up, so slow me down. Any quick questions, desperate questions before I introduce our upcoming CVPR paper, which I'll describe in sufficient detail. UnweaveNet. You've seen the footage of Epic Kitchens, and actually observing them, you notice that people do this, what we're calling unweaving. You go into the kitchen, you start by preparing breakfast, you put the water to boil or the coffee to brew, and then while this is happening, you go and try to clear a little bit out of the dishes, and then somehow the food come out of the toaster, and then somehow the kettle is ready, and you interleave through these activities all the way till the end. And that's what humans typically do. Okay. They do not really start one action and finish it before starting the next one. This is an unusual behavior that we anticipate in action understanding or activity understanding, that someone will do A, B, C, D, and only when they finish it, they will go and start washing the dishes. If you observe actual footage, you see this interleaving between activities. And in this work, we said, okay, we as observers can understand this. And we don't even need to give it complex labels. We don't need to give it the label of preparing coffee or making breakfast, but we know we are switching between activities and we're returning to paused ones. So we wanted to create a model that does the same. It starts observing the video with no knowledge, builds this, what we call the thread bank. So that says, okay, I have recognized now this particular activity. Let's call it blue. So we're not giving an actual label. And then, okay, I see that the person had shifted to something else. And then they had, looks like they had resumed the previous one. So by the end of observing this video, my computer is slowing down, so I hope this is not a bad sign. We actually have this unwoven set of activities of the observation. So this is UnweaveNet. We call it unweaving activity stories. We kind of know where we're going, but I think this is attempt 1 in getting there. Let me show you some of the actual videos. So what you'll see here is the clip number. So that's the starting bit. You'll see this probability of it belonging to a previous thread in the bank or a new one. And then at some point, you'll see this N indicating a new thread. So something new. So this is becoming high enough that you are moving into another thread. And I'll show you the results first, and then I'll show you how we train this model. So again, so the person is actually going through. At some point, they're moving into the next activity. And this is being recognized as a second set of activities. And for a while, we're like confident that we're still in the same thread. There is a continuation. And then we're starting to say, okay, it looks like there is something now, there is a switch into something new, where the person is actually clearing, right? They're taking something and throwing it into the bin. Right. So this is close to where we get, but how do you train a model to do so? So this is UnweaveNet, the overview. It's very similar to the objective. So there is a thread bank, there is like a memory, and there is a controller. The thread bank, which is ZT, gets updated depending on the decision the controller is making for a current clip. Does it belong to a current thread or a new thread? So this is the overview. And the outcome is an updated thread bank that says where this clip will belong. And this is the controller. The controller basically takes the representations of your threads, takes your new clip, has a learned token, whether this is new. So this NT, this is a new learned token. And it's basically trying to learn via a transformer, a simple transformer, the similarity between this clip and the threads, as well as this learned token. And it produces these probabilities out of which you have one of 4 options. Either it belongs to your 3 clips or it's a new clip. That's the only thing the controller is doing. And then the thread bank takes this decision. Where does this belong? And updates the thread bank accordingly, right? Depending on where it is. Simple, easy. We think it's a different way of looking at videos. So we train this end to end because you need to know the features that you want to look at, as well as your tokens and the transformer. The decisions are supervised using this teacher forcing. So at each point in time, you populate your thread bank with the ground truth. Otherwise, it's impossible, right? It's not threads get video. You populate all the Z and you only train for the current decision. And then the loss is imposed on actually making the right current decision. Good, that sounds good. But where will we get the data from? You can't have enough data for this. Luckily, the data naturally gives you some help. And there is prior evidence of using something similar. So we use self-supervised to invent a wealth of these activity stories. We then fine-tune through a small label set, because this can't be enough, but this gives you a very, very good starting point. So that means we take bits from different parts of the same video, because if you take different videos, it's very easy. We take different parts from the same video, we interleave them, creating this fake or synthetic story. We know the ground truth. We can train our UnweaveNet for this specifically. And then we have a small set of labeled sequences, which we've released. So you have around, 1,000. Yeah, these are 1,000 examples with a single thread, 344 with 2 threads in the same activity or thread. And this small data set is public now if you want to play with it. And then let's look at the outcome, right? So any questions on the concept is kind of easy. And the model is, the main thing is to train it end-to-end, because the features are going to change depending on what you're looking at. So what it's capable of doing, so we're going to show you the index clip, the prediction and the ground truth, as well as these decision scores. So it's capable of doing this, like saying this is the same thread. And it's also capable of doing that when you have large motion, like the person turning the flip, right? So it's not really moving with the head. It's actually getting some elements of confidence. So it can confidently say the person is continuing. It's also picking these things we're hoping for, which is you're dicing the meat, you go and rinse the cleaver, and you come back into dicing the meat. These words are our interpretation, right? The model doesn't really give you any words. Or things like this, you're setting up the washing machine, you go and empty the bottle, and then you wash your hands. So it's capable of giving these representations. Yeah, a set of things, like you close the bottle, put it away, and then you go back to stirring contents in the pan. You can see some failure examples. So sometimes it over-segments. So it might produce a bit of over-segmentation. And we have a good amount where the moment at which you decide to switch isn't really exactly the same as what the human believed is the switch, right? So it might decide to switch a little bit one step before or one step after. So again, that's the question of how do you predict or explain that to the human. Look at the paper for details, but it's critical to look at how the self-supervision with the activity stories, the ground truth is helping, compared to a bunch of possible baselines. We're starting a new problem, so there isn't something to directly compare to. Perhaps ego topo, if you've seen this paper, is close in concept, though location-based. So this is UnweaveNet. And if you're interested, do have a look at the paper. Okay, we're doing well. That means I spoke so fast. That's what usually happens when I know we have time. I'm going to present one work on vision and language, because I think it relates to the problems we've talked about until now. So what is video retrieval? Video retrieval is this idea that you have a video and a sentence. In our case, this is our fantastic narrations that we've collected with the dataset. So the hope is I can give you a video, and then from the wealth of possible sentences, the objective is to retrieve the corresponding sentence as close to the top as possible, right? So that's video retrieval. And then it's cross-modal because you can do the opposite. You can start with the text and then look at where your video is. In the first work we've done with this, which is a fine-grained action retrieval, we really focused on separating the action from the objects. So the spaces of verbs from the spaces of nouns. So in this work, we basically we parsed the sentence into verbs and nouns, and we tried to create a space that is distinct. So a space that says this is a putting action, and a different space that says these are meatballs and dough. The objective there is to be able to project every putting together regardless of the object, and to understand all the activities you can do with a certain object regardless of the action. You can still put these representations together and do the standard, but by going through this, what we call multi-view, you're capable of having these intermediate representations and the wealth of possible zero-shot opportunities, which you couldn't have if you kept the sentence together. And the model is very simple. It just says you have F is your video projection. You have two different projections. One is in the noun space, one is in the verb space. And you have to go via them before you can get into the retrieval space. And some things works when you look at these representations. So this is actually looking at examples that maximally activate one of the positions in the noun space. So you see lots of examples of chopping boards in different actions being activated by the same neuron in the noun embedding space, right? And then in the space of verbs, you see the same location being representing lots of open and close of different actions. Again, even though we push for this, this is not yet out there, but I think it's really critical if you want to understand. If you want to know more about our vision and language, again, you've stolen our expert, so you can ask Hazel. I'll move into audiovisual before telling you about Ego 4D. when we collected epic kitchens, before we collected, I used to say, I am a computer vision person, I don't do audio. Until we collected the data, and I think Vangelis came to me and said, if you want accurate start and end times, you have to give the annotators the audio. I'm like, really? And he was showing me lots of examples with opening the water tap or turning on and off the coffee machine. And the audio is a lot more accurate in detecting the start and end time. And then I thought, maybe I'm doing something wrong, because if the human needs that to annotate, then probably the machines we're learning requires the same thing. So we started looking at audiovisual, and I'll tell you about, let's see now whether you'll be able to hear. That's now the evidence. So if you try to locate when the person is actually starting or stopping the blender, good luck. If you have the audio, and sorry if it's too loud. No, that means we haven't shared the audio. Or maybe because I have muted. Let's try again. Hopefully this doesn't produce, no. Okay, so you can look at some of the examples on this data to look at, for example, how strong your smashing the garlic is. When you hear the audio, it's completely separate. And in this paper that we presented in ICASSP, my only paper in an audio-only conference, we actually decided to separate the types of action we do into what we call harmonic sounds. So this is a sound of shushing of water versus percussive sounds. So these are sounds of cutting, where you can see the tick, 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 these percussive things. And this comes from music, the terms harmonic and percussive. And in fact, these are very different as things to identify. When you hear the complete sound, and it's about the frequency of water versus the moment at which you're performing certain actions. And this applies to other data sets. So this is from BGE sound. And again, this is rain versus typing on the typewriter. And you can see that distinction. So in this paper, which, your only paper in a different conference, you think, should I move community? And then you win an award. So we took evidence from neuroscience that says there are two streams in the human that identifies these harmonic and percussive. And of course, previous inspiration in computer vision in the slow fast. And we created auditory slow fast, which was very similar in concept. So it had this idea that you can look at frequency specifically versus temporal. So slow has this low temporal precision and large number of channels. Fast has fewer channels, but high temporal resolution. And you have this multilateral connection to feed from one to the other. And importantly, that's for audio, you have separable convolution, because this has one dimension is frequency, one dimension is time, not like images. Images X and Y are actually homogeneous, but in audio, they're separate. So we had separable convolutions. Right, if you want to look at this, what have detected in slow, what has been detected in fast. But we really like that we created this, particularly looking at epic. And then DeepMind had this paper where, after we finished, that said, the slow fast architecture is actually the richer representation they could find for audio. And they showcased, they built on it, but they showcased that the slow fast approach works on speech, music, and other types of audio sets. So this is really a strong model that's now being used for audio understanding, and Vangelis has really created all these codes and models for you to use. Okay, right. Still, I'm keeping you a bit further from Ego 4D to tell you about one bit of work we've done in understanding how video models had done. Doing this work with Will has increased my confidence in models, decreased my confidence in data sets. And let me show you why. So what are explainable audios? We're trying to look at actual frames. So this is the video. And we're trying to say, okay, we see this video and we're predicting the action. But what's the contribution of every frame in this video to that decision? That means, can I take this, prediction, and can I divide it into prior probability if I have nothing, as well as the contribution of every individual frame? So I know which frames are critical for that action and which frames are not critical. Doing this, there are lots of approaches, but for attribution, for feature attribution, and you should look at the paper for details. But basically, you have to do it an efficient way, but the old-fashioned way. Take that frame, see the response, put that frame back, see the response. So you have to basically compare these two things. You should have this prior probability. You should have one frame, two frames, and then the difference between your predictions are, in fact, the contribution of that score, that frame, in that combination. But there are many possible combinations. And Will has created a very efficient way to be able to do this still while checking it actually is correct. Remember that some frames contribute negatively. If you didn't find them, you'll actually have a better prediction of the score. And again, I think it was the first paper that says attribution can actually be negative. So you have, for example, this is from the something data set, and the class is show that something is empty. The video is someone doing this and then flipping and then putting back. And the model is actually saying those frames in the middle are not really contributing to that class. And like, wow, the model was not really taught that, but it's capable of retrieving that. You're actually having frames there that are lowering your chances of getting the right class. We have a live dashboard that you can play with. And I'll show you some of the examples on Epic that are really transforming my way of looking at videos. And you have two curves here. One is the verb, one is the noun. And the action is opening drawer. And you can see that opening has evidence in the very beginning, but drawer has evidence at the end. Because the motion of opening is visible when you start opening, but what you're opening is only visible at the end. And we're currently asking these models to do both at the same time. And then you have examples like this, which is opening fridge. The class is close fridge, and the model is predicting opening fridge. And if you look at the example, you realize the person starts closing, then opens and takes something and closes again. And the model does pick on that because it can. It's not being told to do anything differently. And my favorite video is this cutting of tomato, where again, every time the knife is on the tomato, the verb is high. Every time the knife is not on the tomato, and this is TRN, this is not even the state of the art of action recognition, while the tomato prediction is well at the very end. Maybe our models are still a lot better than our data, and understanding these attributions are going to really transform what we think about what's missing still in video understanding. Okay. Breather. Still, after collected Epic kitchens, it wasn't as big as ImageNet or How to 100 Million. Is there enough data? So I'll tell you a little bit about Ego40, which is the idea of collecting 3,670 hours of video by 923 participants in 74 cities. So in Epic, we were like 45 kitchens and we were about to die. So there was no way this can be done by one set of individuals. The story you're not going to read in the paper is how do you do that during the pandemic, which we should have written, but we didn't. We started by saying, that's what, we wanted to increase the scale and diversity. That's what Epic Kitchens is. And Jitendra and Kristen at Facebook or Meta, whatever you want to choose now, they said, we want to follow the same example and scale. And the idea was, let's collect 10,000 hours by 1,000 participants. We got close, but we realized 10 hours from one participant was already too much. It was like getting into the boring aspect. We wanted to collect all types of activities, and we started with this, Bureau of Labor Statistics that says, how do people spend their day? We had all these interesting activities that disappeared thanks to the pandemic. We only managed to collect social interactions in the US, India, Colombia, and Singapore. No way we could collect it in Europe. And then we started by saying, previous works had mostly students and researchers. We did not want any students. We ended up with let's minimize students. But this is the big consortium of individuals that collected the data, different types and different interests. Let me tell you about what we've done at Bristol, because every university tried a different route. So we had a social media advert. People were furloughed. I don't know whether the word furlough is popular here, but that's when people left the job and were paid by the government. And there were lots of people who wanted to collect additional money. We would do a meeting with them, make sure they understand what we're doing, answer questions, agree what they will collect. We wanted them to collect things they actually do. Assume someone never draws. We didn't want them to go and collect drawing examples. And then we posted cameras by post. They arrived at their end. We would do another Zoom and train them how to use. Then they would record, upload, check, get their agreement that they're happy for us to use all this data, return the camera, do the payment, and finally, we would de-ID, and I'll show you some examples of how we de-identified the data. Of course, if we knew the amount of effort when we started, we probably would not have done it. But You've seen the wealth of footage in Epic Kitchen, and now we're outdoors. We're outdoors collecting people doing sports, playing with their pets, walking, crafts, drawing, gardening. The wealth of footage in Ego4D is immense, and you can just look at some of the examples. But again, I wanted to show you this because this is not something you're going to find in the paper, which is what did we have to do? We used software, but we had to check every frame for stuff like car number plates. And this wasn't, we knew that. The bit we didn't know are things like what you'll see now, which is, these accidental examples. These were a nightmare. And luckily, we had patient individuals, not me, who could power through these things. They were all around. It was like so hard because when we collected Epic Kitchens, it was one person, one kitchen that, we didn't have much of that. But, you'll see some examples here that needed really careful checking. And even though the individuals had seen them, they did not detect these frames, these reflections. Of course, we did have cases where we had multiple people, so we knew we had to blur faces throughout the video, but lots of other things, despite the fact that you can clarify to them that they shouldn't use personal data, they will have their phone. And of course, there are cases where they will go around and you will see some letters with addresses. So it was fun. Currently, the dataset is available with a good number of modalities. So if you're interested, there is audio for a bit of the data, faces for some of the data not in the UK, 3D scans, stereo gaze, IMU, and some multi-camera data. And then you remember the narrations from Epic Kitchens? They come back. That's how the whole of the dataset was narrated. This was triggered by Meta. They added some cues, which is who is doing it. Is it the person camera wearer or is it someone else? The sentences here is going to be longer and bigger, but they are as dense. That we're still on 13.2 sentences per minute. And everything is available with the narrations and with features. There are slow, fast features, and only yesterday there are omnivore features out there if you want to use. And there are a bunch of challenges. These require additional annotations, so they're not as big as the full data set. And we have 6 open challenges for CVPR and 10 for ICCV. So we're really relying on the community to come together and see what's interesting for them. Of course, I am talking about this, but this is a paper with so many authors, everybody contributing something different. But again, if you're interested in Egocentric, this is the right time. There is definitely wealth of data for you to look at. And I hope I haven't given you a headache. You can look at the paper for details or the website. Final teaser. It's the first time I'm presenting this. So for the past 1.5 years, we have been doing this on Epic Kitchens. We have been collecting pixel level segmentations. These are sparse at the moment, hand done on active objects as you interact with the world, full HD. And we're actually looking at things on the level of detail of, tiny bits of onion, etc. This is coming soon. We already have a wealth of these sparse collections. I get mesmerized when I watch these because I think, now we'll probably be able to ask the questions of what actually are we seeing? Are we seeing the actual objects or are we making guesses purely based on context? Again, the whole idea of Epic is collect the data first, annotate it later. It drives us mad, but the outcome allows you to do things that I don't think you could do if you had thought about only collecting a data for video object segmentation or for pixel levels. And very recently, we're kind of trying to get this done on time, is we have, and again, I hope this excites you as much as it excites me, but we have taken these sparse ones and we're able to do some automatic dense ones that we will clean to our best abilities. But I think the potential of using footage like this for video understanding is completely transformative in the sense that you're seeing objects undergoing massive transactions or changes in the kitchen as opposed to what's out there. Or I'll show you another example of these dense ones. Again, this is like parchment paper, it's actually white. And then you see how people are interacting with these objects. the pen handle. They are starting from sparse, and we're going into dense ones. And what these can do, I think they will, along with attribution methods, hopefully will be able to answer, things we haven't even thought we could answer in video understanding. So, I hope I excited you about one or more of the topics. I hope I haven't given you a headache, though that's doubtful, because I've given you a bit too much. But I'm around today and tomorrow. If you'd like to ask about any of these, or if this is of relevance to any of your work, then I would be happy to tell you more about individual bits of the work. And of course, I always, where we video understanding really depends on the video source. You can't say I'm doing video and expect the same method to work for movies and egocentric. Egocentric footage, we're excited about it. We think it offers plenty of potential. It really brings audio and language into a new perspective. I hope more people will look at what your models are actually learning. We currently have had this large scale dataset for a while. We have this massive scale dataset, and maybe with pixel level segmentations, we will be able to answer so many interesting questions. But I get the fun of coming and presenting this. But this is really hard work of a large team. I believe in the problem, and I'm always impressed by how careful they are. For a while we had to meet virtually. We're back now in person. And if you find yourself in the UK, or if you're interested in visiting us, please ping me or someone in the team, and we would be happy to host you for a day or so, show you what we're doing in person. Thank you very much.
Thank you.
I do apologize for my speed. I'm learning to slow down, but not always successfully.
Right, now we're going to the questions, and I would propose that we switch between the online participants and the offline participants, one question at a time. So who wants to go first? Unmute myself. I can go first. Could you tell us a little bit more about how the amount of work that goes into the labeling process? Like, what's the at a basic level, the ratio of time spent on this?
In my opinion,
maybe both, if you can represent both, I guess.
The sound is muted again. Sorry.
Okay, we don't have a smooth path into annotations. We really change what we're doing as we're doing it. And that makes the process, the beginning of it, to be very hard. And the last bit of it to be very hard, because you can start an annotation campaign, but finishing it off, like the last few videos, you need them done on time. That's also a nightmare. And I annotate. I spend most of my evenings annotating. That's a fact, right? And if you think you're not going to do that, and someone else will do it, you're not going to end up with this outcome. Every one of us, including me, we collected data for Epic when we narrated and we annotated. And I think that changes our perspective and introduces the new collector. We think it's an investment into our understanding, because we think the problems come from the data. But of course, if you think about the value versus how many papers do you get out, you'll feel it's a loss, right? I don't believe in annotation companies, because I don't think they're good when you know what you're doing, but almost always you don't know what you're doing, and unless you do it on your own. Every time we start something, my expectation of the load is probably 1/3 of what we actually do. But every time we've done it, it was worth it. So, but that's my opinion. You should ask the students. Does that answer your question?
Thanks, yeah. Can I go next? Yeah, I did say take an online question.
Oh, it was your question. No,
So the first question here is, can UnweaveNet address simultaneous actions? For example, if we use audio at the same time, we cannot understand if an action like turning cattle has finished.
Not at the moment. The clips are too short. They're 16 frames. So the assumption is within those clips, it's one thread. But no, at the moment, it can't. It's at the level of activity. So the assumption is that you might be doing two actions, but not two activities. But no, it's currently not within the scope of what we can do with this model.
Then Pascal, can you speak up and then?
Sure. So what is different about Ego 4D than other domains? It's grassroots. If I look at language domain, for example, what you see now is a big company makes a trillion parameter model, and that can do the whole world. So why is the video domain so different in terms of research, and will that change?
The video domain is not different. So how 200 million is collected from YouTube, right? The egocentric, we don't yet have egocentric hardware. So we don't have a wealth of egocentric footage on Facebook or on YouTube, right?
How to 100 million is also from academia.
No, I mean, people didn't have to collect the footage. They were available on YouTube, right?
Maybe let me rephrase.
Okay.
Where is industry?
Where is industry? Well, Ego4D had Meta, had Facebook online
Okay.
as a partner.
Yeah.
They paid for the whole set of annotations. We didn't pay for that. But again, it's like 11 universities. So, and even the people at Meta, we're still talking about Kristen Groom and Spencer Murray. These are people between academia and industry. Industry is currently interested in Egocentric because of the crazy metaverse concept. Don't record me. Yeah, so I don't mind why they're interested. I think the problems are interesting to me. That's why I am doing this. But currently, there is this idea that we'll all wear stuff, whether it's virtual or augmented. So there is an increased interest, crazy increased interest. And they're like, you know, without mentioning names, if A is doing something, B wants to do it currently. We don't mind if they're helping our cause. But remember, in Google Glass, there was a phase where they came in and they left and we stayed. And that's why we're ahead of the game, because they have their waves and we're not there to solve a particular wave. We're there because I think the problem is really interesting.
Next online question that we got is, thank you very much for your interesting and insightful presentation. Could you elaborate on how you think adding time of flight or double cameras or other 3D sources would add to the understanding of the models?
Yeah. If they are as good sensors as RGB, I think they would be very helpful. In my postdoc, I did RGBD when kinetics came to play. The quality of the depth, especially on small objects, is so bad that currently, if they solve it, if the sensor is good, of course it will help, because I can really see the grasp and what you're doing. But the current level of quality on these types of, because they're focusing on this big, big objects, walls and floors and chairs, right? When they move into mugs and small bottles, yeah, why not? But we did record in Ego4D some stereo, and there is some 3D scans with egocentric footage for people interested. I think they would be great if we can do. However, depth in Ego isn't as sensitive as depth otherwise, because you're always roughly at the same depth. You're not really moving depth drastically. And that's why I would say, if you want to work in that domain, the depth accuracy has to be very high to distinguish between me here and here. And that's currently not what current sensors are targeting at all.
I think we have time for one last question. Kes?
Yeah, Dima, thank you for a great talk and for all the massive amounts of work that you're doing. Please keep going. I got triggered by your last slides on the presentation. Really nice. I want to have it. But my question is, it seemed that apart from the segmentation one, in all of the other works that you presented, that you take a rather holistic view to video, in the sense that you take the video as it comes and you compute you do your representation learning. Is there a reason why you ignore locality, like explicit locality?
Because current models don't really target that specifically as yet. It's very difficult to really understand what bits of the image are relevant to each action. If you try to fire some of these, grad com stuff, at times they make sense, at times they don't make sense. You can't do what people do in third person, where the person is where the action is, because the hand is not really where the action is. Sometimes it's the whole sync, sometimes it's within the hand. So we don't benefit from a good one detector, person detector or hand detector. So we can't utilize that wealth of work. I would love for people doing that to come and tell us what we can do. So we do spatial temporal. I think temporal is underexplored. I don't know how much spatial temporal is only spatial. So I think temporal is where you need the to kind of, so that's where we are. And that's why the frame attribution was on what's the impact of every frame in the video, which wasn't done before. It was only kind of spatial. Like this frame, if I take it, does it matter?
And with that, we are pretty much on time. I would like to thank the
Miracle.
speaker again for all the amazing talk and the answers to the questions, and with this new hybrid format.
We
Thanks
didn't
again.
do too badly. Apologies for the mess ups.
Thank you.